Good morning, class. Today we are going to discuss normalization. Having gone through mapping and the different lectures that we have seen, so today we are going to look at the other approach of deriving tables in databases. So we looked at ER, and then we translated the tables to the logical design using a process of mapping. And we said that at the end of it all, when you're done with your mapping, all the tables or schemas that you'll have generated at that time, they will be normalized up to the third normal form. And in most cases, we're saying that most database designers decide to normalize their tables up to the third normal form. So unless you want to proceed to the fourth normal form and the other forms, at that particular moment in time, you are good to go. So today we are going to discuss normalization. The part of the objectives of what we are going to discuss is we're going to look at the purpose of normalization, the problems that are associated with redundant data, then identification of various types of update anomalies such as insertion, deletion, and modification anomalies. And then we shall look at how to recognize appropriateness or the quality of the data of the design for the relations. We'll not stop at that. We shall look at the issues of functional dependencies, which looks at the relationship between the different attributes within a given table. Then we shall try to go through the process of normalization, and then we shall see how we will be in position to identify most commonly used normal forms, which is usually the first, second, and the third normal form. So normalization is a technique for producing a set of tables with desirable properties that support the requirements of a user or a company. So normalization can be used in two ways, database ways. One, normalization can be used as a bottom-up approach to database design, or it can be used in conjunction with the ER model. So the previous methods that we've been using of generating an ER model, then we went to enhanced, and then we went to mapping. So that, and then after the resultant tables that we had in ER, in mapping, this is now the second approach to normalization. However, you can also start straight away using the bottom-up approach like I had described in the database design, where you're looking straight away from your requirements. You go ahead in trying to identify the attributes, the relationship between the different attributes in a given entity or entities. So either way, that particular process enables us to get tables that are free from redundancy. So normalization, we are saying the four most commonly used normal forms is the first, second, third, and then Boy's code. The underlying aims of normalization is one, to try and reduce on redundancy, and also try to a certain level minimize on data inconsistency, and then also trying to avoid or prevent any kind of anomalies that may result as a result that may pop up as a result of the redundant data. And these anomalies could be insertion, deletion, or modification anomalies. So basically, if your data is redundant, it means that your data in the database is prone to insertion anomalies, deletion anomalies, and modification anomalies, as we shall discuss these things. So what's data redundancy? When someone talks about data redundancy, is data redundancy the same as data duplication? So the major aim of relational database design is one, group attributes into relations to minimize on redundancy, but also you try to minimize on your storage space. So when you are in the process of normalization, or when you are in your data, when you're designing your database, the two major aims that you're trying to do is one, try as much as possible to reduce on redundancy, because when you reduce on redundancy, then you are going to reduce also on the storage space of your medium or your hard drive. So the problems associated with data redundancies are illustrated by comparing the following relations, as we shall see them. But before we go to redundancy problems, I thought that we need to understand what redundancy is and what duplication is, because sometimes these two words are used interchangeably, but they are actually different. And in appreciating the difference, we shall, in the process of looking at our data, you will see that this data is redundant and the other is not redundant. So duplicated data is present when an attribute has two or more identical values. So for example, if you have a table and a particular table has values that are the same, that data is duplicated. A data value is redundant if you can delete it without information being lost. So you can have duplicated data, okay, where you have a particular attribute having more than two identical values, for example, and you can have a program within a university, or you can let's take an example of let's take an example of an entity called student. And an entity called student has an attribute called date of birth. Now that attribute called date of birth, remember there are different students who could be born on the same date, who could be born within the same year, and they are born in the same month. So that means that particular attribute called date of birth will have duplicated values for the different students in the university. That is duplication. Whereas data redundancy, okay, we're saying that data redundancy, how do you know that this data is redundant and this one is not redundant? You know that data is redundant if you delete a particular value of a particular record and the information about it is not lost, or the meaning of the information about it is not lost. Once you have that, then you know that you have redundant data. Otherwise, if you lose that data, or if you delete that data from a given attribute, okay, and then the data loses meaning, okay, or the data is lost, then that means that that particular record was not redundant. We shall see what I mean by both. So redundancy is unnecessary duplication. So what does that mean? That duplication to a certain extent is allowable within a database, but redundancy is completely not acceptable in databases. You have these two tables, table A and table B. Table A is non-redundant duplication. The word non-redundant duplication. If you look at student name, there is a student called Sarah with an ID number 1, and then you have another student called Sarah with ID number 4. D4. This is typical in any setting. You will be in a school, you will be in a class where two people have the same names, but the registration numbers are different. So those people are completely different people. So when they're stored in the database, that particular attribute or column will have duplicated data. So A, duplication, but not redundant. This duplication is not redundant. Why? Because these are different students. A student D1 called Sarah and a student D4 called Sarah. They are completely different students. They have different IDs. Now, table B. Table B, we assume that, okay, let's delete Sarah from the data, from the table B. So deletion of duplicated data but non-redundant data values causes the loss of information. That is what I explained in the previous slide. So we are saying by the mere fact that you have deleted Sarah, it means that now we don't have a record of Sarah, or we don't have a record of this student who is supposed to be taking on the ID number D1. So implying that information has been lost, implying that Now this data is inconsistent. So the data value is redundant if you delete it without information being lost. So it would have been redundant if you had D4 Sarah and another row that had D4 Sarah. Then that data would have been redundant, because the moment you delete, if we deleted D4 Sarah, just the one record, we would have remained with the other record. So I think that kind of throws light on what exactly I am talking about. Now here we have a scenario. This is a scenario. We have three tables. Now we have a table. You have a table called staff and branch that are in one database. You have two types of databases. One database decided to record the details of the staff in a separate table called staff, and the details of a branch in a separate table called branch. And then you have another database that has recorded staff branch. They merged both records together. They don't want to waste time, they merged all these records, they merged all this information of a staff and a branch into one table. So those are the two databases. I'm trying to explain the concept of data redundancy. So if you look at it, the table called staff has a staff number, has a name, a position, salary, and the branch number, implying that these members of staff belong to this particular these particular branches. And then we have a relation called branch. A branch has the branch number and the branch address. Remember, the branch number is mapped onto the branch address. Like your name is mapped onto your registration number. Your registration number corresponds exactly to your name. So you have a branch number that corresponds to a branch address, and then you have a telephone number. This is one database. This database decides to concatenate everything together into one table. Now, this is what we're saying. We're saying that the aspect of redundancy, in table staff branch, there is redundant data. How? Because the records of a branch, have been captured for each and every particular staff member. The records of the branch have been captured in each and every particular staff member. What am I saying? If you look at B001 and then the branch address, we could as well eliminate any, because when I say B001, I know that B001 is mapped onto 8 Jefferson's Way, Portland, etc., etc. Now, implying that even if I deleted B001, I will still be in position to know where staff number S00 work, because we have the branch address. Likewise, if I deleted City Center Plaza from the database, I will be in position to know where S3250 works because of the presence of the branch number. So this particular relation called staff branch has redundant data. So they're saying that the staff has redundant data. The details of a branch are repeated for every member of staff located at that particular branch. In contrast, the details of each branch appear only once in the branch table. So if we go in the branch table, if we go back in the branch table, the details of each branch, they are recorded once. You have B001 and 8 Jeffersons, blah, blah, blah. So this particular table does not have redundant data. No, it does not have redundant data. Likewise, here when we come to this particular staff, we have only recorded the branch number. So when you say this particular staff is attached to B001 as the branch of that particular staff member, when you go in the branch table, we know that B001 corresponds to the branch address. So these two tables are not redundant. So the moment we remove B001, we shall not be in position to know where staff S1500 works, because we have deleted this. So we are saying that redundancy, redundancy is such that when you delete the value of that particular attribute within a table, information is lost. So implying that the moment you delete this, we shall not know where this particular staff member works. So implying that staff relation is not, it doesn't have duplicated value. The same thing applies to this particular branch table. So because of redundancy, these tables are subject to anomalies. Okay, anomalies are inconsistent or error-prone situations that may arise during the process of working with the data in the database. So these anomalies could be insertion anomaly, deletion anomaly, or modification anomaly. We are saying an anomaly is that kind of situation where the data, if at the moment of either inputting data or deleting data or updating data, you're going to have issues, okay, when processing those tables. And those issues are usually caused by redundancy of the data. So those are the three types of anomalies. Then so what is insertion anomaly? What is insertion anomaly? Now, if we go back to this table, okay, these are the three tables, but in two different databases. If we are going to insert a new member of staff in this particular table called staff branch in a database called X, okay, and we are inserting a new member of staff. So if we're inserting this new member of staff, we have got to also capture the details, all the details of a branch. And all these details of the branch must correspond the details of the other records within the same table. So for example, you're going to have another member of staff called S1000. Now S1000, who is maybe called Fred etc. Okay. When on the branch number and the branch address, we have got to capture the correct details of branch number. So if the person is going to be in branch B002, we have to put B002 and then capture the details of the branch address plus the telephone number, and be sure that the details of B002 are corresponding to the other details of this particular branch for the other records. So because here you have another record of Robert Chin and you have a record of Marie Martinez. So these details have got to be the same all through. So at the time of inserting data, it becomes hard because now you have to make sure that you enter branch number. And so you're repeating the same data that otherwise would have been done once. So what happens if I want to include a staff number in this database that has split the staff and branch? So here you just add your Fred with this S1000, and then all you need to do is to capture B002 as the branch number, because already in your database you have a table called branch that will tell us that B002 corresponds to City Center Plaza. So that is with the insertion anomaly, that it becomes very hard. You are bound to experience problems or inconsistencies or errors when you are inputting data in a table that has redundant data. I hope that is clear. And then we go to the update anomaly. Okay. So now we go to the update anomaly, modification anomaly. We go to the modification anomaly. So we are saying that if we want to change the value of one of the columns, okay, of a particular branch in the staff branch number, for example, you want to update the telephone number of B002. We must update those records of all the staff that are located at that particular branch. Otherwise, if you don't do that, then the database is also going to have inconsistent data, because it would mean you're going to have some staff members with a different telephone number and the other also with a different telephone number, yet they are of the same branch. Let us go and we see what I am talking about. Update anomaly. Let us assume, here we are. Let's assume that we want to change. Now the branch has changed the telephone number of this city center plaza. It has been changed to, let's say, a particular number. What does that mean on update? It means that we have got to change this telephone number across B002 for each and every particular member of staff who is working in B002. We have got to go and we change their telephone number in this particular field. We are going to go and look for them. Take an example, if you're having over 1,000 employees and you have to go, who are working in City Center Plaza, you have to go on adding their updating their telephone number. Otherwise, if you don't do that, you are bound to have a scenario where you have all these particular members of staff of B002, but they have different phone contacts or they have different phone numbers for that particular branch. And yet it is only one branch. So that is the challenge with this table if you want to update it. However, if I wanted to update the telephone number in this particular database that has only the branch table, it's just about going into this particular record, you change the staff, you change the what? You change the telephone number, and that's just about it. So these other members of staff who are attached to B002, we shall know by default that these particular members of staff, their phone numbers have changed, because remember, these two tables are already going to be referenced. Remember, it has this branch number, which is a foreign key. So we shall know by default that these members of staff, this is their telephone number, and it's only updated in that table only once in the table called branch. But here you will have to update it in each and every particular record where those particular members of staff appear to be working in branch B002. That is what we call the modification anomaly. And then lastly, we have what we call the deletion anomaly. Now, the deletion anomaly, look at again, this is the database that has staff branch. Look at this particular individual called Staff Peters, who belongs to a particular branch called B003. Imagine this is the table that has all this information. Now, if B003 means that it is the staff at Peters is the only member of staff who is representing B003 as a branch within this database. So if we are going to delete at Peters, who is the last member of staff in that particular branch, if we are going to delete at Peters, what does that mean? It means that we are going to delete even the records of the branch number B003. So the moment you delete at Peters, there's going to be that assumption. First and foremost, the details of branch 003, all of them are going to go. And then if anyone else is entering into the database, they will assume that there wasn't any other record, there wasn't any other branch that was called B003. Yet the branch still exists. Only that this person was the last member of staff in that particular branch, and now that member of staff has been deleted. So that means we no longer have any details about B003. That is if you're going to use this approach. However, if we want to delete in the other approach, you have these two relations, staff and branch. Now you want to delete this particular staff member called at Peters. So we shall just delete this at Peters from the database, but we shall not affect the details of a branch. Why? Because we have a separate relation that is holding information about the branch. So the only person that we are deleting, or the only person that we are eliminating in our database, is this particular individual who is also attached to the branch called B003, but deleting him will not affect our relation called branch. So now, you can see what happens with data redundancy, that your data is prone to having anomalies like insertion anomaly, like what I have explained, deletion anomaly, like what I've explained, and updates anomaly. So, in essence, okay, so in essence, it is very, 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 very suicidal, okay, to have redundant data in your database. It's suicidal, it's not acceptable. That is why we use the process called normalization to help us to reduce or minimize on data redundancy. So we are going to look at the aspect of functional dependency in part 2 of this video. Thank you.